Okay, so hi guys. This is like the third time I'm trying to do this video. So, obviously we know increasing and decreasing intervals. Now, I really want to briefly explain what an inflection point is, as well as what concavity is. And I'm gonna go ahead and erase this part here, because obviously I was doing it wrong, and well, yeah. So let me go ahead and just this part. So obviously we know how to do Maxima and Minima, or at least if you don't know how to do that, you know, you can go back to my previous videos. But that is what that's one of the things that I went over in this calculus playlist. Now concavity means that, so when something is concave up or concave down, that really means, so the best way I can explain it is, this is what concave up is, like this. And then concave down is like this. That's the best way I can explain it. An inflection point is really just the middle of those two things, where it is concave up and concave down. And an inflection point is basically where f2 prime of x equals 0. The second derivative of f of x is equal to 0, right? Now this is how it looks when it's concave up, and then concave down, and then concave up again, concave down, etc. I feel like this should be concave up, so like it should be more like this. And then concave down should look more like this, right? But I did my best in sketching it, but usually your book would say it, how it would look when it's concave up and concave down. Now, the thing is that, so there's also something we call inflection points, and inflection points are literally the middle of where those two things happen. So like, when it goes from concave up to concave down, what is the point at which it goes from concave up to concave down, or vice versa, right? Or concave down to concave up. So basically what I'm trying to say is that at this specific point right here, that is the inflection point. Similarly, over here is an inflection point. And then again, over here is another inflection point. Right? That's honestly the best way that I can explain it. So, but the main thing is that it's not about, we don't have to focus too much on the definitions of, or the graphical definitions of it. I mean, it is very important to know, but the more important part is knowing how to algebraically find them. And so that's what we're going to do in this video. Now, so basically it says, for the following exercises, determine part A, where the intervals where f is increasing or decreasing. So that first one is pretty easy. Let's say we have, so obviously we have f of x equals, I'm going to just do a very simple function, f of x equals x squared minus 6x. We want to find where the interval is increasing or decreasing, right? So the way that you're going to do it is you're going to go ahead and find f prime of x, and this is the calculus way to do it. So you would say f prime of x equals 2x minus 6. You would then set that equal to 0. So then you would, so basically f prime of x equals 0. So set it equal to 0, and then you would say we would add 6 on both sides, and that would give you 6 equals 2x, divide by 2 on both sides, and you get x equals 3. Now you're going to draw a number line from negative infinity to 3, and then 3 to infinity. Because that is where this is what we call a critical point, or a critical x value, right? Now, so basically, we want to know where it's increasing or decreasing. Now, I believe I had said in a previous video that to know where it is increasing or decreasing, we have to find we have to test x values from negative infinity to 3, but we have to use the derivative, okay? So, to know where it's decreasing or increasing, we can find, so, give me 1 second, guys. Okay, sorry about that, guys. So, you're gonna test an interval from negative infinity to 3, and then union 3 to infinity, but you're gonna test an interval for which, basically for the derivative, right? Now, if I test, so obviously we can do 0, because that is between negative infinity and 3, right? So if I do 0, I get f prime of 0 is 2 times 0 minus 6, right? So then that would be 0 minus 6, which is negative 6. So right here, it's decreasing, right? And then from 3 to infinity, you can test x equals 4. 2 times 4 minus 6, that's 8 minus 6, which is 2, and that's positive. So it's increasing. So that means that basically the graph is increased, or so f of x, so basically the way that you would say it is f of x is decreasing from negative infinity to 3, and then increasing from 3 to infinity. That's for the first part. The second part says, find the local minima and maxima of f, okay? And I am going to just do this example because I don't want to make this video too long, but basically, this one says, so basically, to find the local minima and maxima, we know that the graph is decreasing like this, and then when it goes greater than 3, it's increasing, right? So what does this mean? This means that the graph is going to have a minimum. Anytime you have it's like, I believe they teach this in algebra. When you have something like this, a parabola like this is what we call a minimum. If it's the other way around, which is like this, we usually call the middle point, we call it a maximum. Okay. So, so it's very obvious that because this goes from decreasing to increasing, it's like if I kind of do a Cartesian plane, and I go from negative infinity to 3, right? I go from here to here. It's decreasing, and then it's increasing again. And this is just a rough sketch. It's not the actual graph, right? That means that basically the graph is going to have a minimum. But what is that minimum? That minimum is at x equals 3. We know that. So the minimum is at x equals 3. And if we evaluate f of x at x equals 3, we get f of 3 is going to be, and it'll be, so we have f of x equals x squared minus 6x, So f of 3 is going to be 3 quantity squared minus 6 times 3, right? So then we have 9 minus 18, which is negative 9. So this is f of 3, right? Now, that means that the minimum, or the actual minimum value, or the minimum will be at the point 3, negative 9. And so that is for part B. And now it's saying part C says find the intervals where f is concave up and concave down. So part C wants us to find concavity. So that means we're going to have to set f2 prime of x equal to 0. Now, obviously, we know that basically, so give me 1 second. We know that f2 prime of x is 2. So, because we know that we had said that f prime of x was 2x minus 6. So, again, I'm just going to go ahead and repeat what I said. F of x is x squared minus 6x. F prime of x is 2x minus 6. And f2 prime of x is going to be equal to 2. That means that on the graph, we're going to have something like this. This is equal to 2, so it's going to be like this. Okay. This is y equals 2. So the inflection point in reality is wherever f2 prime of x equals 0. However, because this graph is so this one's a little bit trickier because this one, basically the inflection point would be where it's going in the middle of concave up and concave down. So give me 1 second. Okay, so here, because the graph cannot equal to 0, because f2 prime of x cannot equal to 0, there are no inflection points. Okay, we're gonna do one more. So let's just do one more. Let's do x cubed minus 6x squared. Okay, so again, we have f of x equals x cubed minus 6x squared. We want to find following. We want to find the increasing or decreasing intervals, as well as the minima and maxima, and the concavity. Or actually, I'm sorry, the concavity and also the inflection points. So to find the intervals of increasing or decreasing, we're going to find f prime of x. We have 3x squared minus 12x, right? That's a derivative. And we're going to set it equal to 0. So we have 3x squared minus 12x equals 0. That gives us 3x times x minus 4 equals 0. And then that means that 3x equals 0, or x minus 4 equals 0. So then that means that x equals 0, or x equals 4, right? And let's see. So that means we're going to do a number line. So we're going to go ahead and do a number line. And we have here x equals 0, and then it's 1, 2, 3, 4, right? It's going to be So basically we have two things. So it's going to be two things. It's going to be x equals 0. Let's just pretend that's where 0 is. And then here's 4. Now we're going to test the following x values. And we're going to do the following. So we're going to do, so the intervals are negative infinity to 0, 0 to 4, and then 4 to infinity, right? So let's test, let's do negative infinity to 0. Negative infinity to 0, excuse me. We're gonna do f prime of x, okay? So we have, so obviously f prime of x, like we said, is equal to 3x squared minus, sorry guys, give me 1 second. Okay, sorry about that, guys. So f prime of x is, we know that f prime of x equals 3x squared minus 12x. And we want to know, so we want to know basically where it's increasing or decreasing. That means that we want to know where is f prime of x. So if f prime of x is negative, so basically if this is less than 0, then f of x, if f prime of x is less than 0, then f of x is decreasing. And if f prime of x is greater than 0, then it is increasing. That is, like, for whatever point we choose, right? So let's say that we choose -1, for example, right? So we have f prime of -1 equals 3 times -1 squared minus 12 times -1. So that'll be 3 plus 12, which is 15. So that's positive. That means it's increasing in this interval. Now 0 to 4, we can choose x equals 1. So f prime of 1 is going to be, so 3 times 1 squared minus 12 times 1. It's 3 minus 12, which is -9. So it's negative right here. So that means that it is decreasing at this interval. Now 4 to infinity, we can choose x equals 5. So f prime of 5 will be 3 times 5 squared minus 12 times 5, which is 3 times 25 minus 60, which is 75 minus 60, which is really positive. So that means that here it's increasing. So that means that f of x is increasing in the following intervals. So negative infinity to 0, union of 4 to infinity. And then it is decreasing, so f of x decreases at 0 to 4, which that is an interval. That is not a point. That is an interval. Okay. And then, well, that's how you find increasing and decreasing intervals. And then to find so let's see, hold on. To find So now we want to know the local maxima and minima of f. It's like I said, if it's increasing, so we know the increasing and decreasing intervals. It's increasing from negative infinity to 0. So let's just say this is negative infinity and then this is 0. It is increasing from here to here, right? And then from 0 to 4, it's decreasing, so it's going like this. And here is 4. So it's like that, decreasing. And then it's increasing again. So basically like this, hold on. Like this, and then it's increasing again from 4 to infinity, right? So basically, let's see here. To find the local minima and maxima, we know that at x equals 4, at x equals 0, it's going to have a maximum value. And at x equals 4, it's going to have a minimum value. So this is minimum, and then this will be maximum, right? And then, so we want to know what those are, right? So the minimum value of f of x, we know it occurs at x equals 4, but we want to know exactly where that is. So we're going to say, so because we know the critical points are at x equals 0 and at x equals 4, we're going to plug that in for f of x. So if I say, so again, so writing down again the function of f of x, we have f of x equals x cubed minus 6x squared, right? So so basically f of 0 will be, obviously it's going to be 0 because we have 0 cubed minus 6 times 0 squared, right? Which is equal to 0. So the minimum value, or I'm sorry, the maximum value, I'm going to say the maximum value because that's where the maximum value occurs. So the maximum value, I don't know if they say y equals 0. I mean, I would say it occurs at y equals 0, but I would also say in coordinate form the maximum value is at y equals 0, but I would also say it's at 0, 0. Now the minimum value would be at x equals 4. So basically you would say you would plug in 4 for x, for f of x. So basically you have f of 4 is going to be 4 cubed minus 6 times 4 squared, right? So then that means you're going to have 64 minus 6 times 16, right? And that is going to be 64 minus, and you have, so 6 times 16, that is going to be, hold on. That's 96, right? And 64 minus 96 is negative 32. So the minimum value would be at 4, so the minimum value would occur at 4, negative 32, or at x equals 4, y equals negative 32. And so that's how you find the maximum and minimum value of the function, right? Let's see. And now the inflection points. This is literally the last part. The inflection points are just going to be wherever f2 prime of x equals 0. So we know what f prime of x is. Now we want to know where f2 prime of x equals 0. So we're going to go ahead and do, so we know f prime of x is equal to 3x squared minus 12x. And if we do f2 prime of x, that's going to be 6x minus 12. So basically f2 prime of x equals 0. And if we do 6 x minus 12 equals 0, we're going to add 12 on both sides. And then we have 6x equals 12, and we divide by 6 on both sides, and then that's going to be x equals 2, right? And so basically we have, again, it's going to be from negative infinity, and then we're going to go from negative infinity to 2, and then 2 to infinity, right? So basically, we're going to test an x value at which it is concave down. So, for example, if we do x equals 0, we get 6 times 0 minus 12, and that's 0 minus 12, and then that's negative 12, right? So then it would be, this would be negative, which means it is concave down at this interval, right? And so then we're going to go from 2 to infinity. So then we have, we're going to go ahead and plug in x equals 3. So if we plug in x equals 3, or if we plug in 3 for x, we get 6 times 3 minus 12, and that's 18 minus 12, which is 6. So then we have, this is positive, right? So then that means that here it'll be concave up at this interval. So that means that the graph, so f of x, is concave down from negative infinity to 2, and then it is concave up from 2 to infinity. Okay, and that is how you do this problem. And finally, the inflection points are literally where you set f2 prime of x equal to 0. So the inflection point, all you have to do is find f of 2. Because that is where the second derivative, that is when we set the second derivative equal to 0. So the inflection point just means at that specific x value, what is y? And it is a point, and that is what we call an inflection point. So we set it, so basically we want to find f of 2, so then we know that f of x is x cubed minus 6x squared. So again, I'm going to write my function down. So then we're going to go ahead and find f of 2. So it's going to be 2 cubed minus 6 times 2 squared. So then we have 8 minus 6 times 4 which is 8 minus 24, which is really, it's gonna be, let's see, 24 minus 8, that is, so, well, it's gonna be negative 16, right? 8 minus 24, excuse me. So the inflection point is the following. 2, negative 16. And that is how you do this problem. Okay. So, that is it, guys. If anybody has any questions, please let me know. Please like, comment, and or subscribe. And, with that being said, guys, thank you so much for watching. And I will see you guys in the next video. Bye, guys.